This is Ms. Martinez, and in this video we are looking at the unit circle. I'm looking for you to be able to use exact trig ratios, to identify exact trig ratios for common angles using that unit circle. So let's get started here. What is the unit circle? It is a tool that we use in trigonometry to give exact trig ratios. And it's called a unit circle because it has a radius of just 1 unit. So if I plotted this point here on the circumference of the circle, it would have a radius of 1 unit. And then that little triangle, well, the horizontal distance would be x, and the vertical distance would be your y value of that point that's on the circumference. And even if you didn't know theta, that would be okay, because you could still find x and y and your radius. Now what's really fascinating and what makes a unit circle so conventional is sine of your theta would be your opposite, which is your y, over your hypotenuse, which in this case is 1. So your sine value for your theta, if you're working in a unit circle, is just the y, your height. And similarly, your cosine is that adjacent, which is your horizontal distance, over your radius of 1. So cosine of theta is your x value. So that point there could be expressed as cosine theta sine theta. The coordinates there could be expressed as cosine theta sine theta, because x, whatever x is equivalent to cosine theta, and your y is your sine theta. So let's get started here with some of the common angles in a unit circle. The first common angle I want to talk about is a 45-degree angle. And that would create a triangle that was a 45, 45, 90. So those unknown side measures have to be the same. You could call them both A. So we're going to solve for the measure of those sides if our hypotenuse is 1. Simplifying, you would have 2a squared equals 1. Divide each side by 2. And then take the square root of each side. Now, when you're taking the square root of a rational expression, you take the root of top and bottom, and we need to rationalize our denominator, which will give us the square root of 2 over 2. That would be the measure of both of those legs in your triangle, which means sine of 45, sine is your y value over 1. So sine of 45 is square root of 2 over 2. And cosine of 45 is the adjacent over the hypotenuse, which simplifies to just square root of 2 over 2. That's our first common angle. And that point would be located at square root of 2 over 2, square root of 2 over 2. Let's look at another common angle. It is the 30-degree angle. And in this 30-degree angle, the shortest side has a measure of 1/2. Now, to find that other side, we're going to use our Pythagorean theorem to help us out here. All right, so we're looking for that third side, knowing that the hypotenuse is 1 and the short side is just half of that. So we'll go ahead and square, and then we'll subtract 1/4 from each side, so that'll give us 3/4. Take the square root like we did before, and that means take the root of the numerator and denominator. And there you have it. That side will be the square root of 3 over 2. That will be its measure. Which means that sine of a 30-degree would be 1/2, because it's just your y value, and cosine will be your horizontal, your x value. So that point is square root of 3 over 2, comma 1/2. And the way I remember that, cosine being x and sine being your y value, is it's kind of like, you know, the coordinate is x comma y. It's in alphabetical order. Well, which comes first alphabetically, cosine or sine? Cosine does. So cosine is x, followed by, in alphabetical order, sine, that's the y value. The last angle, common angle I want to talk about is when you have a reference angle of 60 degrees. Okay, so this is the same triangle as we saw before, 30, 60, 90. So the short side is now the horizontal and the long side is the vertical, which means sine of 60 is square root of 3 over 2, and cosine of 60 is 1/2. All right, and that would be the coordinate there. So we're going to find the exact value for the following here. We're going to find cosine of 120 to begin with. And I've sketched out the unit circle here, and I've made some markings on them. Those are our common angle markings. Those with reference angles of 30, 45, and 60. So let's begin with 120. 120 would be located just 30 degrees past your 90-degree mark. And when we draw our triangle, that means we're going to have a reference angle of 60. Your short side is going to be 1/2, but because we moved horizontally in a negative fashion, it'll be negative. And vertically we went up, so it would still be just square root of 3 over 2. Cosine is going to be that adjacent, which is negative 1 over 2, that x value. All right, now let's do tangent of 315. Okay, so 315, in which quadrant is that? That's going to be in our fourth quadrant, and it is that which is a reference angle of 45. So our two legs are going to measure the same, square root of 2 over 2 horizontal, but then vertical is negative. Now, what is tangent? Tangent is really the ratio of sine over cosine. Tangent is sine divided by cosine, so that's going to be square root of 2 over 2 divided by itself, which is 1, but because the signs were different, we're talking about negative 1. All right, now let's look at secant of 180. 180 is, well, that horizontal line right there, and you can't create a triangle, but we do know that that point, the x value is negative 1, and it will have no height, no y value. Secant is the reciprocal of cosine of 180, and cosine is the x value. What is our x value? It is, for this point, negative 1, so our final answer here will be negative 1. 1 divided by negative 1 is negative 1. All right, so that was an example of using your unit circle to give exact trig ratios. Let's do similarly, but now using radian measure. We're getting better at using radians. Let's figure out in which quadrant is 5 pi over 4. That is in your third quadrant, and it is a reference angle of 45. Now, for both the horizontal and the vertical, they are negative movements, so it's negative square root of 2 over 2. And the sine is the y, so you're looking at negative square root of 2 over 2. All right, we're now going to work with cosine of negative 2 pi over 3. That means we're going to go down instead of rotating up. We're going to go rotate down and over. We're going to again be in our third quadrant, and we're looking at a reference angle of 60 degrees here. The short side, we're going to work with negative 1/2, and the long side, that is negative square root of 3 over 2. And cosine is the x value, so that will be negative 1/2. All right, lastly, let's do secant of 3 pi over 2. 3 pi over 2 is equivalent to 270. It's one of those quadrant angles. And that point, you can't really sketch a triangle, but the point would be at 0, 1, because our radius here is 1. So you went down 1 unit, the y value, but secant is cosine. Oh, I'm sorry, I shouldn't have put square root of 3 over 2. It's cosine of 3 pi over 2. So cosine is the x value, which in this case is 0. So 1 divided by 0 is undefined. So there is not a value defined for secant of 3 pi over 2. It is undefined. All right, now last example here that I want to work with you guys. Let's say that we were given the trig ratio and now we want to find the angle measure. Well, it's really helpful to kind of have an understanding of, in your quadrants, the x and y values, if they're positive or negative, so you know when you get positive or negative values what quadrant you're working with. In the first quadrant, both x and y are positive, so your cosine and sine are both positive. Then it would be negative cosine values and positive sine values. In the third quadrant, both are negative, cosines and sines. And then lastly, your cosine will be positive in quadrant 4, but sine will be negative. Now what about tangent? Because I'm already anticipating that we're going to see tangent of an angle. Well, tangent, again, is the ratio of sine over cosine. So tangent is positive in the first quadrant, and tangent is positive in the third because negative divided by negative is positive. So here's how I remember this. They're all positive in the first, sine, cosine, and tangent. But then only sine is positive in the second. The only one that's positive in the third quadrant is tangent, and the only one that's positive in our fourth quadrant is cosine. And so the way that, I think it was Gabriel Bayona helped me to remember this. He was a student and we were trying to think of a way to remember this. And so when you read this from quadrant 1 to 4, it's all sin tan cos, which sounds kind of like all sin, we all sin, right? And that if you look at the bottom, it looks almost like the word tacos, all sin tacos. So that's how I remember it. I know it's kind of silly, but it helps, all sin tacos, because I love tacos. And I sin. So there you go. Okay, now let's try and answer the question. When is sine 1/2? Well, 1/2 was one of the ratios when you worked with 30-degree and 60-degree measurements, but we're looking at sine, which is the height, being 1/2, being that short measure. So that would be right here, which is going to be at 30 degrees. And where else is sine positive 1/2? It would also be in our second quadrant. And that's going to be 150 degrees. So again, how did I know that? Well, I thought about 1/2. That's going to be the short side, the short height, because sine is my y value, and that is when you have a reference angle of 30. It's the short side is opposite the 30. Now, let's try cosine. When is cosine 1/2? Well, that is going to be when your short side is your base, which happens when you're working with a 60-degree reference triangle. And when else would it be, when else would your cosine be positive? Well, let's look at our little helpful reminder here. All sin tan cos, cosine is also positive in your fourth quadrant, and that angle would be 300 degrees. Lastly, when is tangent going to be -1? Well, that means that sine and cosine had to be the same ratio, but the signs were different. So the same ratio, when does that happen for sine and cosine? It happens when you're working with a 45-degree angle. And that, when would it be negative? When would sine be positive but cosine negative? That happens in the second and in the third